All right, let's dive right into this explainer. We're all so used to AI just firing back an answer the exact millisecond we hit send, right? But what actually happens when AI doesn't just react, but pauses to truly think? Today, we're exploring the brain power budget, a fundamental shift in model reasoning introduced in Google's Gemini Enterprise Agent Platform. Here's our roadmap for today. We're going to cover the power of the pause, exactly why AI needs to think, break down Gemini's specific thinking levels, and finally, how you can budget your AI brain power.
So, Section 1, the power of the pause. Like I said, we're totally used to those lightning-fast outputs. But what's really going on when an AI generates a thought process before speaking? To you and me as users, it might just look like a slight delay, but under the hood, it's incredible. Instead of just blindly predicting the next most likely word in a vacuum, the model is actually building an internal scratch pad. It's running through trial and error, doing the heavy lifting to actually solve a problem before it formulates its final output.
The official documentation calls this the thinking process, literally the generated internal reasoning a model goes through before giving you that final answer. Think of it exactly like a human working out a gnarly math problem on scratch paper before handing over the final number. By taking the time to show its own work internally, the AI unlocks significantly stronger reasoning capabilities. Moving right along to Section 2, why AI needs to think.
Look, not every single prompt needs deep philosophical pondering. If you ask an AI to pull a specific company name out of a short email, that's a low-complexity task. It just needs to give you a quick, immediate answer. But complex reasoning, say asking an AI to debug 1,000 lines of Python, solve a crazy multi-step logic puzzle, or formulate a comprehensive strategic plan, that demands the AI to internally show its work. Honestly, if it rushes that kind of job, it will fail.
So here's the absolute crucial takeaway for us. By enabling this thinking process, you aren't just putting speed bumps in front of the model. You are fundamentally upgrading its ability to reason. You're trading just a tiny fraction of speed for a massive, massive leap in accuracy and pure logic. All right, Section 3, Gemini's thinking levels explained.
Starting with the Gemini 3 models, Google dropped a powerful new tool into their API, the thinking level parameter. It completely simplifies how you configure this cognitive effort. So instead of wrestling with insane back-end prompt engineering, you literally just have a simple dial to control exactly how much thinking budget you want to allocate to a query. And it's super interesting how this budget defaults across their model ecosystem. For example, Gemini 3.5 Flash defaults to a medium thinking level. But Gemini 3.1 Pro, that thing is built for heavy lifting, so it defaults to high for maximum reasoning right out of the gate. On the flip side, the 3.1 Flash-Lite is designed for absolute blazing speed, so it defaults to minimal. Google automatically tailors the default brain power to match what the model's primary use case is.
Now, a quick heads up on that minimal setting. When you use it, you're restricting the model to use as few tokens as possible, which is absolutely perfect for low-complexity tasks. But you've got to be incredibly careful here. The docs explicitly state you must provide thought signatures in your request. Basically, a thought signature is a structural cue you pass to the AI so it knows exactly how to format its brief thought process. If you forget it, boom, the model returns a 400 error. Nobody wants that.
Oh, and there's one major technical caveat you absolutely need to keep in mind. If you have thinking enabled, you cannot use fine-tuning. Right now, it's an either-or situation. If your architecture relies heavily on fine-tuned, highly specialized models, you're going to have to weigh that against the benefits of this dynamic thinking process. Which brings us to our final part, Section 4, budgeting your AI brainpower. You really should think of this thinking level parameter as your literal brainpower budget, because every single time the AI thinks, it eats up tokens, and tokens cost compute and, well, money. But you have ultimate control. You can crank down the thinking level on easy tasks to save tokens and lower your latency, or you can spend those tokens on the high setting to buy some seriously strong reasoning for your most complex logic. This naturally builds into a highly practical workflow. By following these 3 steps, you're not just sending prompts anymore. You're acting as a cognitive manager. First, you assess the task complexity. Second, dial that thinking level appropriately. And third, optimize your balance of speed versus reasoning. You are deciding exactly how much time and energy the AI should spend on your specific problem. I want to share this exact quote from the source documentation because it perfectly summarizes why this matters so much. Quote, "Thinking models are capable of stronger reasoning capabilities in its responses than equivalent-based models. That pause to think directly and measurably elevates the quality of the AI's output. It transforms a reactive text generator into a deliberate, powerful reasoning engine.
So, now that you actually have the dial in your hands, and you understand the trade-offs between speed, token usage, and profound logic, how are you going to budget your AI's brainpower today? Will you prioritize lightning-fast responses, or will you let your AI take a deep breath and truly think? Thanks for joining me for this explainer. See you next time.